Hi, everybody. Welcome back. So last time we talked about the dplyr library, or actually the last set of videos that we've looked at. We've been going through the dplyr library, which, if you remember, is named such because it's kind of like a set of pliers that help you deal with data frames. And for most of the class, we've called them tibbles. But I do want to make it actually clear that today, for this particular part of the lesson, we are going to make a distinction between tibbles and data frames, and I'm going to show you why we have to treat them slightly differently. Um, this is simply because whenever you're interacting with other people's legacy R code, you may run into data frames. And I want you to be aware that they do things a bit differently. They're still storing rectangular data, and most of them, by and large, a lot of the functionality for data frames and the functionality for tibbles are going to be the same, particularly if you're using dplyr. However, this lesson is basically a caveat emptor lesson, so buyer beware, so that you are aware of the differences in dealing with older code. One of the reasons why I had to write this is because I'd have students that come to me, they've learned a lot of this material, but then they say, oh, but my professor gave me this code and it's not working the way that I was expecting it to work. And it's because their professor wrote the code 5, 6 years ago, maybe more. And yes, it sort of works, but it's not doing what they were expecting because this older code is using data frames instead of tibbles. So I want to spend the time here talking about the differences, or briefly talking about the difference. So particularly, we're going to look at there's three different example data sets that we're going to use. And then we'll look at the differences in row subsetting, the differences in column subsetting, and the differences in relational subsetting. We are not going to be talking about joins because, in my experience, the dplyr approach to joins is far superior to the base R approach to joins in every conceivable way. The dplyr approach to joins will use very similar syntax to another language called SQL, which has been, or SQL, which has been the standard for doing database joins for 60 years, probably, 55, 60 years. So because dplyr seeks to emulate SQL, that means that the skills you learn in as far as the filter, the select, the case when, the joins in that approach, they're going to translate to other languages because they're all built on top of SQL. So here's the example data sets. Another comment here. Throughout the semester, I've used _df to just mean a tibble. However, because the point of this part of the lesson is to compare tibbles with base data frames, I'm not going to be using df at all. I'm going to be using tbldf to mean the modern tibble, and I will use data frame. I'll have it underscore data frame to mean that it's an older data frame so that you can clearly see in the code which one's the old one, which one's the new one. Okay, so the three data sets that we're going to use, the heroes data set that we've used in class, I've got code to make it. There's the Framingham data set. It's from the local control package. So I want you to take some time and go ahead and install that package now. And then the DS Labs data set, there's a version of Gapminder from DS Labs. You may have another version of the Gapminder data set. Just go ahead and grab this one because it's a smaller subset of that data. Anyway, so here's the heroes database, or database. Here's the heroes tibble. This is the Framingham. This is going to be a data frame. I'm going to have a data frame and a tibble version. So basically, there's the data frame right here, and then we have a version of it where we've turned it specifically into a tibble so that we can compare the two side by side. And then also the Gapminder data. There's going to be a data frame version, which is the older data standard, and then there's a tibble version. So just to recap, we're using underscore data frame to mark that the data set is one of those older data frame objects, and we're using underscore tbldf to say that it is specifically a newer tibble object so that we can compare the two. All right, getting into row subsetting. If you have a base data frame, base R data frame, and you subset a row, you're going to get a one row data frame. So in contrast, if we have a tibble, we can use, obviously we can use the same single square bracket operator with the one to the left of the comma. That means that we're selecting rows. So you remember that the number on the left-hand side of the comma is for rows. If there is a number on the right-hand side of the comma, that would be columns. If there's no number on the right-hand side of the comma, that means all of the columns. And if there's a number here, but no number on the left-hand side, that means give me all of the rows for that column. Okay, so for tibbles, we have the option of using the single subset operator or the slice function. Both of these will return one row tibbles. So for rows, pretty simple. They do basically the exact same thing. You start with a data frame, you end with a data frame. It just has a lot of rows versus one row. For dplyr, you start with a tibble, you end with a tibble. They just have one row. Columns are where things get weird. Okay, so if you remember, both tibbles and data frames under the hood are lists. So we had access to the single subset operator, we had access to the double subset operator. We've also mentioned the pull function, and we've also talked about the select function. So there's a lot of ways. Oh, and the dollar sign. Forgot about the dollar sign. Can't forget about the dollar sign. So there's a lot of different ways that this can go weird. Hopefully you pick up that tibbles are very consistent in what they do. The base R data frames are not consistent in what they do. All right. So if you move the one from the left-hand side of the column to the right-hand side, the left-hand side of the comma to the right-hand side of the comma, now we're selecting columns. A data frame will return an atomic vector of length equal to the number of rows of the data set. So the Framingham data set, we said that we were selecting just the first 20 rows of this so that we have a smaller data set to work with. And then if I have a base R data frame and I say, give me the first column, it actually returns not a data frame, but a one column atomic vector of length equal to the number of rows. However, if I use the exact same single subset operator without a comma, now I get a one column data frame. So we don't have a lot of consistency here with the base data frames. If I use the double subset operator, now I get back to the atomic vector again. If I use the single subset operator with a comma, but I'm doing named subsetting, I'm going to get an atomic vector. If I use it without the comma, the single subset operator, I get a one column data frame. If I use the double subset operator with names, I get an atomic vector. So we're seeing sometimes we get atomic vectors, sometimes we get one column data frames. There's not a lot of consistency here. Now, the most infuriating thing is back here, when I used a comma to select one column by name, I got an atomic vector. But now all of a sudden, if I add two columns, suddenly it's a data frame. This is very, very frustrating because if you wanted to write code that says, give me all of the columns that match this criteria, but in some data sets, you get matches that are multiple columns, but in other data sets, you get matches that are only one column, then the structure of the data changes entirely. We go from, if we have multiple matches in one version of the data set, we get a data frame, which is technically a list under the hood. It's non-atomic, so we have to work with this thing as if it's a non-atomic vector, a rectangular non-atomic vector, a data frame. But if for whatever reason, in this particular version of the data, we only match one column, well, suddenly we get back an atomic vector. Oh my goodness, the first time that I dealt with this writing my own functions, because I was writing a package and I was expecting that all the time there would be multiple matches in the column. So I wrote it this way, expecting like, oh, it's going to give me a data frame every single time. And then one of the data sets that we got from one of the testing cases, because I had released like an alpha version of the package for other people to test it, other people in the working group. And somebody tested it on one of their data. They ended up only having one column that matched, and it returned, instead of a data frame, it returned an atomic vector, and it broke the code. So it very frustrating whenever I had to deal with this back a long time ago. And there is an argument to the single subset operator called drop, or I think it's dot drop, and we had to work with that argument. But anyway, you can see here when we're dealing with base R data frames, it's very inconsistent. Okay. Because it's switching from different classes of data. And as you can see, at this point in the semester, you should appreciate that the class of the data changes how R operates with the data entirely. Another thing here is if I try to use the double subset operator with 2 columns, it's going to say, no, I don't like that. It's going to give you an error. And then finally, for the base data frames, we can use the $, and it will return an atomic vector. Okay. Now, we're going to compare this to dplyr. dplyr, particularly with tibbles, everything is supposed to be very consistent. So if I select the first column by position, I get a tibble. If I select the first column using the single subset operator with a comma, notice this is very different. I don't get that atomic vector anymore. I still get a tibble. If I select it by position without the comma, I get a tibble. So all of these, the same one column tibble, and that's if I select it by position. If I want to select by name using the select function, I get a 1 column tibble. If I want to use the single subset operator with a comma, so this before gave us an atomic vector, now 1 column tibble. If I use the single subset operator without a comma, still 1 column tibble. So you can see that there's consistency here, that every time whenever you're going to be using these subset operators on a tibble, you're going to get back a tibble. The structure of the data, the class of the data does not change. Select function, again, if we only select 1 column, we still get a tibble. If we select 2 columns, we still get a tibble. So we don't have to deal with the class of the data changing based on the selection criteria. Same here. If we use the single subset operator with a comma this time, we still get tibbles no matter what. We use it without the comma, we get a tibble. Now, this is where it changes slightly. We can use the pull function. This is kind of like the $. This will give us the atomic information, and we can pull with by specifying the name as a symbol or as a character string. So that gives you a little bit of flexibility. So if you need to write code, say, okay, find me the column that matches this, then you can specify it as a character string. If you're just typing it yourself, you can just type the symbol. The $. Also works. This double subset operator by both position and name also works. So these are really take away from this that when working with tibbles, it's a lot easier to predict what the output is going to be. So the times where you want it to start, where you want to start with a tibble and end with a tibble, that's going to happen. If you want to end up with an atomic vector, if you want to start with a tibble and end up with an atomic vector, you have to specifically ask for that, either with the pull function or with the $sign operator or with the double subset operator. Okay. All right, we're going to pause here and dig into relational subsetting, because the relational subsetting here is a little bit different. All right, see you next time.